Okay, so welcome back. This video is kind of a follow-up to my previous video where we discuss understanding some of the basics of bench power supplies, and we also mixed in a bit of a review of the power supply I show up here in the corner, the Dr. Meter PS-3010, which I think implies it's a 30-volt, 10-amp power supply. It's got a single output, 3010DF. And I mentioned some things in that video, and I wanted to pursue them a bit in this video and show you some more things to be aware of when you buy a low-end power supply like this, things that might not be intuitively obvious. So in the previous video, I talked about the dials here, the two voltage setting dials and the 2 ampere current setting dials. They've got coarse and fine. And I mentioned that these dials, the position, the absolute position of these dials corresponds to a value. So for example, on this top coarse dial, as I turn it from far left, which is at 0, as I turn it to the limit, clockwise limit, it goes from 0 to 30 volts. And if I'm like halfway there, that will be 15 volts, okay? So whatever you leave these dials on will correspond to an actual value, and that applies for the voltage and also the current. So we said that if, for example, I crank this dial all the way up to 30 volts, and I turn off the power supply and go do something, and a week later come back, when I turn this back on, there will be 30 volts appearing on the output because I have set that voltage at 30 volts, and the maximum voltage out of this power supply is 30 volts, so it's always there. So you have to be very careful when you turn on this power supply. Make sure you turn everything down to 0 if you have any concerns about too much voltage appearing. So that's fine. I mean, that's good to know about the voltage. What about in constant current mode? You might think, well, if I'm limited in constant current mode, then this shouldn't really be a problem. So let's take a closer look at that. So let's say, for example, in the previous video, I had a 0.5 ohm 100 watt resistor, and I connected that across, here's our power supply terminals. I connected that across the output, these output terminals, and let's say that I wanted to limit the amount of current through that 0.5 ohm resistor to, say, 5 amps, all right? So I want a 5 amp constant current limit. And again, you set the constant current limit down here on these bottom 2 dials. So if you think about it, okay, if I'm limiting 5 amps output with this load connected, and I'm in 5 amp constant current mode, how much voltage, what's the maximum voltage that will be generated across these terminals to push 5 amps through this load? Well, simple math tells you 5 times 0.5, I times R, is the voltage that's generated. So 0.5 times 5 is 2.5 volts. So you might think, okay, well, the maximum voltage that will be generated across this load is going to be 2.5 volts because I've got 5 amps constant current set and I've got a 0.5 ohm load. So, you know, you're never going to get more than 2.5 volts. And certainly if you have this voltage dial set up to 30, you don't have to worry about it. You're only going to get 2.5 volts, right? Well, not so much. And that's what we're going to talk about in this video, some of the downsides of buying a very low-cost power supply and some of the things you have to be very careful about. Okay, so here on the bench, I've got my power supply, I've got my oscilloscope, and I've got my 0.5 ohm 100 watt resistor. And what I'm going to do, first start the power supply, nothing connected. I've disconnected everything from the power supply. And as we showed in the previous video, it starts up in constant current mode which means it wants you to crank this up a bit until it jumps into constant voltage mode. So now you've allowed some current to come out. So let's say I'm going to crank this up to maximum, all right? 28.96 volts. I'm in constant voltage mode, and I turn off the power supply. Okay, so now that I've got this power supply set at 30 volts, this dial is turned all the way clockwise at 30 volts. I have connected my leads going directly into the oscilloscope, but there's no load connected. I bypassed the load, I'm going directly into the oscilloscope. And I've set this oscilloscope on single shot because I want to see what the voltage waveform looks like when I turn this power supply on, okay? So now I'm going to turn on the power supply, and there you go. You can see the voltage. I've got 10 volts per division, goes up to 30 volts, and everything's nice and clean and good. Okay, so now let's see how it performs in constant current mode. So I've got my half ohm resistor connected, I've got my oscilloscope, and I've got my power supply. Everything's turned down to 0. I'm going to turn it on, and I'm going to set this for 5 amps through a half ohm resistor, which means I should only need 2.5 volts. So I'm going to crank this up a bit, get in constant voltage mode, and really I can set this at anything, right? I can set this at 30 volts because it's going to be limited to whatever this, 2.5 volts or whatever that's needed to push 5 amps. So right now it's 1 volt out, and I'm going to crank this up to 5 amps. And here we are at 5 amps. Okay, so I'm set at 5 amps, about 3 volts, and 14 watts. Okay, so now let's see what happens to the output on the scope when I apply the power supply. When I turn it on, we're expecting it will go up to maybe 2.5, 3 volts, and then we'll have our 5 amps. So we turn it on. Wow, look at the peak. Okay, let me turn this off and let's zoom in on this. So if you can see here, I've got 2 volts per division. So 2, 4, 6, 8, 10 volts. And then it drops down to about 2.5 or 3 volts. So you can see it went way, way, way up. And then suddenly realized, hey, wait a minute, I only need 2.5 volts or 3 volts to push this rated current. And here we are way up at 2, 4, 6, 8, 10 volts. All right. So you got to be really careful with this. A lot of it depends, I think, on the fact that this dial, this voltage dial, is set to maximum. And I think it initially jumps to this value and then overcorrects and then says, hey, wait a minute, I don't need this value, I only need 2.5. So you can get, you expect you're going to get 2.5 volts, you can get 10 volts, you can get more than that. So you have to be really, really, really careful in what you hook up and when you hook it up and what the ratings are. Okay, so, I'm not sure to what extent this is a design flaw or it's just the fact that it's a low-price device. There's really no voltage limit you can set that I know of. So, here's a reproduction from my scope of that or similar trace where it goes from 0 up to about 12 volts when all you need is like 3 or 4 volts down here. Only because that dial is set to the maximum 30 volts and it jumps up to a high value under the 30 volts and then comes down to something more realistic. And you can see it does it in about 20 milliseconds and in 60 milliseconds it's down to the normal required value. So again, be very careful of these devices. This device, again, I wouldn't, it's a real annoyance. I think you can get better power supplies for the money. Again, this is $85 or $90. Think twice before you buy these power supplies. And if you're using this power supply, make sure your voltages are turned down to only as much as you need them to be. because you can get even some transient high voltages that you may not be expecting. So anyway, I hope this helps. Take care and have a really good day. Thanks.